Okay, so today we're going to talk about polygons, and it says our goal for today is to identify and classify polygons and find angle measures of quadrilaterals. So a polygon is going to be a plane figure. What does plane figure mean? Well, it means that it's flat, that it's a 2D figure. Okay, it's formed by 3 or more segments, and the segments are going to be the sides of the figure. Okay, the segments means that there are no curves on the figure. The sides intersect exactly 2 other sides at endpoints. Okay, an endpoint is called a vertex. So what this is saying is these points on the figure are called, each point is called a vertex. Multiple points are called vertices. Okay, the sides are segments, they intersect other segments. Consecutive vertices are 2 vertices that are the endpoints of the same segment. Okay, so consecutive vertices would be like A and B, or B and C, or we could even say E and A, etc. Okay, a segment that joins 2 non-consecutive vertices of a polygon is called a diagonal. So if I pick a vertex, so for example, if I pick E, if I connect to A, that would be considered the consecutive vertex. Okay, if I go across, that would be a diagonal of the figure. So EB would be a diagonal. I could go across to C. That would be a diagonal of the figure. Okay, if I connect to ED, well, that's just a side of the figure. That's not a diagonal. There's more diagonals on this figure. If I select vertex D, I could go from D to A. I could go from D to B. Those would be other diagonals. Okay, so it says use the polygon at the right to answer the following questions. The first one says name all of the vertices. Again, the vertices are the points on the figure. So the vertices would be A, B, C, and D. Name all of the sides. Well, the sides are the segments. So AB would be a side, BC, CD, and then the last one would be DA. Name all of the diagonals. Well, I could connect A to C. That would be a diagonal. I could also connect B to D. That would be a diagonal. Okay. If I connect C back to A, that's really the same thing as segment AC. So there's only 2 diagonals for this figure. Okay. The next one says, is the figure a polygon? And explain your reasoning. So this first one we would say yes, because it's flat, it's closed, there's no curves. Letter B would be, no, it's not a polygon because it has these curved pieces. Letter C, this figure is not closed, so I would say, no, it's open, so it can't be a polygon. On the bottom of the page, there's a list of polygons by the number of sides. So 3 sides is a triangle, and there's a diagram. 4 sides is a quadrilateral. There's a diagram. 5 sides is a pentagon, and so on. The heptagon you need to close, and then you will want to study these. You want to know the names of the polygons for this unit. Okay. All right, on the back page, we have some practice. It says, decide whether the figure is a polygon. If so, tell what type. If not, explain why. So for letter A, we would say, yes, this is a polygon. Well, what type is it? It has 1, 2, 3, 4 sides, so we would say this is a quadrilateral. Okay. Letter B has 1, 2, 3, 4, 5 sides. It is called a pentagon. Letter C, what I see here is that these lines crisscross, so it really creates 2 open spaces, or 2 enclosed spaces. I would say no, the lines cross each other, so it creates 2 enclosed spaces, so that doesn't count as a polygon. Letter D, we would say no, because this figure is still open. Letter E, this is closed, it's flat, there's no curve, so this is a polygon. If I count the number of sides, 1, 2, 3, 4, 5, 6, 7, 8 sides is an octagon. And letter F, I would say no, because it's curved. Okay, the last part for today is the quadrilateral's interior angle theorem. Okay, it says the sum of the measures of the angles of a quadrilateral is 360. So what they're saying here is if I add these 4 angles together, it should total to 360. A little bit of an explanation of why. If I pick a vertex and I connect to every other vertex of the figure, what happens here is, in my figure, I've created two triangles. I know that a triangle has a sum of 180 degrees. So if there's two triangles, if I take 180 times 2 for the two triangles, I get 360 degrees. And I can always, from any vertex, create two triangles in that quadrilateral. Okay, so what I do here is I'm going to add up the angles, and I'm going to set them equal to 360. Okay, so for my first one, I'm going to say 68, it doesn't matter where I start, so 68 plus 75 plus 163 plus b has to equal to 360. From here I combine like terms, so if I say 68 plus 75 plus 163, I end up with 306 plus b equal to 360. If I subtract the 306 from both sides, what I'm left with is b is going to equal 54 degrees. Okay, how could I check my work? Well, if I go back and I add these four angles together, 163 plus 68 plus 75 plus 54, it should total to 360. Okay, on the next problem, these boxes, remember that means that this angle is 90 degrees. So here I'm going to have 90 plus 127 plus b plus 90 is equal to 360. If I combine those like terms, I get 90 plus 127 plus 90 gives us 307 plus b is equal to 360. From here, if I subtract the 307, I'm left with b equaling 53 degrees. Okay, once again, we can check it. We could say 127 plus 53 plus 90 plus 90. So the four angles, they total to 360. We're good to go. On the next one, I'm going to start with this angle right here, this 24x plus 3 plus 86 plus 100 plus 75 equal to 360. Like I said before, it doesn't matter where I start here. I just like to go around it in order to make sure I don't skip any angles. So here I'm going to have 24x plus, if I say 3 plus 86 plus 100 plus the 75, those add up to 264 equal to 360. If I subtract the 264 from both sides, I'm going to be left with 24x equal to 96. And when I divide by 24, I get x is equal to 4. Okay, now to check my work, I would go back and plug it in. I would say 24 times 4 plus 3 would give me 99. And how do I check it? Well, I say 99 plus 86 plus 100 plus 75. Those four angles total to 360, and we're good to go. All right, the next one, like I said before, it doesn't matter where I start. I'm going to start with this piece right here. So 17x plus 8 plus 66 plus 110 plus 74 has to total to 360. So I get 17x plus 8 plus 66 plus 110 plus 74 adds up to 258 equal to 360. If I subtract 258 from the 360, I'm going to be left with 17x equal to 102. If I divide by 17, then I'm going to find that x is equal to 102 divided by 17. Oops, 102 divided by 17 is going to be 6. So x is equal to 6. From there, if I want to check my work, I can say 17 times 6 plus 8. 17 times 6 plus 8 would give me 110. How do I check it? Well, I want to add these four angles together. 110 plus 66 plus 110 plus 74 totals to 360. Last one, 84 plus 2x plus 118 plus 2x plus 68 plus 90 equals 360. Combining like terms, I have an 84, a 118, a 68, and a 90. So 84 plus 118 plus 68 plus 90 gives me 360 plus, I have a 2x plus 2x, so that's 4x equal to 360. If I subtract 360 from both sides, what's going to happen is I'm going to have 4x is equal to 0. And some students would say that they're done. You need to divide by 4, but 0 divided by anything is just going to be 0. Now, kind of weird that x equals 0, but if I go back and plug it in, this would be 2 times 0 plus 118. So what's the measure of this angle? It's really just 118. This angle would just be 68. So I can add these four angles and see, do they total to 360, which they actually do. We added them in the equation. So they total to 360, and we're done.